Continuing with these few things in the 10 to 100 kilogram range, we are looking at now desalinating a cubic meter of water. So water is considered one of the big problems that climate change will exacerbate in terms of quantity, quality, and access. And there is always this idea that there is so much water in the oceans, why can't we just desalinate it? Of course, that's possible, but again, it depends on the carbon footprint in this context, but also how that may or may not change quantity, quality, and access, physical access, economic access, moving from the coast inland and so on, and as well as what to do with all that brine that is left behind when you do massive scale desalination. Nonetheless, desalination has been going on for a while. Here, just coming back to the carbon footprint, it has zero carbon CO2 equivalent if it is solar powered when technology permits, jumps to 5 kilograms CO2 equivalent on average with a reverse osmosis plant in Sydney using electricity from coal. So wherever we have a solution that requires energy, we must always go back and look where the energy is coming from, whether it's EV, whether it's desalination, whether it's carbon capture methods or whatever else, right? So 23 kilograms is a massive amount you will get if the thermal desalination plant is inefficient, but these are kind of somewhat subjective calculations. Globally, desalination accounts for perhaps 0.6% of our footprint, but this is rising fast. As water becomes an issue, this is going to get bigger and bigger in its total contribution. So here's the desalination capacity in thousands of cubic meters per day. So you are looking at this already is a bit old. It's from 2009 and it would have changed massively by now. So you're looking at United States, Netherlands, Antilles, Chile, and of course the monsters are down here in the Middle East. Saudi Arabia is way above everybody else, and UAE and so on. So this is hot, dry desert regions, but they can dig money out of the ground by drilling for fossil fuels. And there are accompanying issues as well in terms of doing farming in places where it's stunning to do farming, like deserts, selling oil for the world, which is the main culprit of all our carbon footprint, and so on. But we are all in this together anyways. Looking at desalination plants, operational desalination plants, desalination capacity, and operational desalination capacity. We are looking here going from the 1960s, and you can see that the number of plants have jumped seriously over time coming into 2020. Operational desalination plants have increased as well in terms of number of desalination plants, now going close to 20,000 that are constructed, and over 15,000, almost 17,000 that are operational. If you zoom in to this period since the 1980s, and you will see how the various methods are contributing to the total desalination. Okay, so remember, desalination is a solution, but it depends on how we do it, and the carbon footprint can depend on how it is done, and then that doesn't necessarily address the other issues of access, okay, quantity, quality, and access. Moving on to a pair of pants, 3 kilograms CO2 equivalent for my favorite old nylon traveling plants. This is by the author. Nylon, which travels well, packs well, cleans well, dries fast, etc., is much less CO2 intense than cotton jeans. 6 kilograms CO2 equivalent for the cotton jeans, but you probably read many articles that say that jeans just do not need to be washed at all. Okay, I go very long times without washing the jeans, and sometimes people suggest microwaving them, but be careful because they've got these metal buttons and zippers which can do serious damage if you're not careful. So natural materials may sound greener, like cotton, but the footprint can tell you a very different story. So again, life cycle analysis becomes critical for all these things. The annual carbon footprint of buying and washing clothes, when you include the clothes, the washing, and the drying, if you remember, and washing, can add quite a bit. So typical North American clothing and laundry habits, clothes contribute quite a bit, but also washing and then drying. Jumps to over 400 kilograms CO2 equivalent. Cotton clothing worn into the ground, typical North American laundry habits, it's a bit lower than the average we can get out of it. But cotton itself is a crop that one has to be careful about. Water guzzling cash crop that causes all sorts of other problems. And if you buy quick drying, built to last clothing worn into the ground, no tumble drying, then you can bring your carbon footprint to quite a low number per year. Okay, so again, you cannot always track everything. You don't need to feel so guilty. Plus, you cannot even find the information when you go looking for it necessarily. Okay. Here are some tips for keeping the total impacts of your clothing to a minimum. Buy stuff that is easy to wash and dry. Buy stuff that is built to last. Don't replace clothes too many times either. Wear it and use it until it falls apart or you pass it on. Buy secondhand. This is not... Even when I give my clothes to somebody in the family might say they don't want to wear used clothes. Whereas in the US, we are used to going to second-hand clothes and buying good quality clothes. So it's a cultural kind of attitude, behavioral issues as well. Repair things rather than throwing them out. Donate or recycle clothing rather than putting it in trash. This is quite easy to do in countries like India, but also in the US, where Salvation Army and others do collect clothes and sell them back. Of course, in the second-hand clothes, that's what you get. Favor synthetic fibers over natural ones for a reduction in carbon footprint of the washing and drying, for example. And how easily they travel. They tend to be lighter as well. Jeans can be heavy, right? Steak, 2 kilograms CO2 equivalent if it is a raw 4-ounce beef steak. So we talked about cheeseburger, which has a lot of processing that's involved, transportation, etc. Steak can also travel. There's a lot of export of meat, of course, from, let's say, South American countries and Australia, or even India and China to the Western world. A steak has about the same impact as 25 bananas. If you have one per day, that would be more than 700 kilograms CO2 equivalent per year, and it would be equivalent to 1,000 average car miles. Do you like your steak? Well, you might want to enjoy it based on this knowledge you have about already what we know in terms of just how water intensive, land use intensive, and food intensive production of beef is. And the additional thing we often don't talk about is the N2O emissions. We are looking at carbon footprints. We talk about ruminants and methane emission. We talk about feedlots and other impacts, but N2O is another big contributor. Looking here at nitrous oxide emissions from agriculture in general, greenhouse gas emissions, this is from this book chapter here. So you have a pasture here with plants that are doing nitrogen fixation. Often you have addition of nitrogen fertilizers and effluents emanating from the cattle as well, like urea and urine. volatilization and ammonium production, which gets deposited into ammonia, which gets nitrified into nitrate and gets leached into the water, and then denitrification can release nitrous oxide, and nitrification can also directly contribute to nitrous oxide. So things are complicated. If you look at total emissions in million tons of CO2 equivalent per year versus emissions embodied in trade. So what is the difference? Basically, beef is produced somewhere. So often we look at footprints that are computed where the beef is produced. But when beef gets exported and consumed elsewhere, there is embedded carbon that's traveling with the meat, right? So if you look at beef, obviously it's much higher than pork, which is much higher than chicken, but all of them have had increasing trade. So embodied carbon in the trade is been increasing as well, and you can see that the embodied carbon can be quite different for beef and pork and chicken. So traded carbon has now become almost the same as embodied carbon for all of them, but there are differences in the details. If you look at a global map for each type of meat analyzed, presenting country scale emissions due to meat consumption, so this is about embodied carbon again. Beef here, you can see where the largest beef emissions happen. China, India are up there, as well as US, but the Brazil and Argentina, I think, are way above everybody else. When you look at chicken, China dominates, and if you look at pork, China again dominates. China is a heavy meat consumer, but maybe the COVID and the experience with COVID will change things. It's not clear. There are some early numbers that say that there is large-scale reduction in meat consumption because of various concerns that are legitimate and based on fear, but the question is always how quickly the system will return to normal. So if COVID is disappearing, hopefully never come back again for, let's say, a few decades, then slowly people forget, like what happened after the Spanish flu of 1918. It probably killed between 50 and 100 million people, but what remains in terms of the behavioral change from that time? Not so obvious, right? So there is a problem called recency, where people only remember recent events that are traumatic or even good events and forget about the past. Okay, so all those sorts of things matter, but again, just be aware of all these things.